Let's start with the algebra section, first topic. Okay. Simplifying it started off nice and easy. So all you had to do was collect like terms here. You got your 2x and your x. Some of you would have helpfully actually written on there, you know, put some marks underneath the like terms, and then you can see 2x minus x just gives you 1. Then 5y and 3y, 5 plus 3 gives you 8. So that's what gives you the answer there.
Sir?
Yeah?
I had D, but it's crossed out. Like it says
Okay, I'll have a look at it. Again, if you've got any queries, like maybe something's been marked wrong, or maybe you don't understand the explanation I give, maybe just hold off until the end so I can just jet through the answers as quickly as possible. Okay. Make a note separately rather than make notes on your paper, because otherwise it's kind of like they'll say, oh, well, you might have changed it afterwards or something like that. Okay. So that's why another reason why it's useful to have your own book. Okay, the perimeter of this triangle. Let's have a look. Now you've got to do these three sides here. Perimeter means you've got to add up all of the lengths. So that's why you can see this working over here. So again, it ends up being a collection of like terms. You've got 2x's here. That gives you 2x. When you do 2 minus 4, that's minus 2. Plus 6 gives you the plus 4. Okay, so when you collect those like terms, that part's probably the trickiest. That ends up with the 4 there. So 2x plus 4 is your perimeter. Okay, moving further. If x equals 7 and y equals 4, find the value of this. So you had to substitute them in. So instead of x, you had to do 2 times 7, right? So that's what you can see here. Instead of y, you had to do y equals 4. So there's that minus 4 there. 2 times 7 is 14, and that's what gives you 10. Okay. Further down, okay, maybe I'll try and zoom in a little bit, make that a bit easier. Is that better?
Yeah, that's good.
Okay, good. So here, you had to do two things. You had to expand this, and then you had to, again, collect like terms. So when you expand 2 times x was 5, you can think of, remember, it's kind of like the 2 has to shake hands with the x and with the 5, just, you know, being polite. So that's why you get 2x plus 10. The minus 4 is just kind of hanging out on the side. It's not inside the bracket, so that's why it doesn't get doubled, okay? The 2x, there are no other like terms. 10 minus 4 is 6. That's where that answer comes from. All right, moving down. Simplify. Now, with your index notation, if you remember what n to the power of 5, what it stands for, it's n times n times n 5 times. So if I wrote that out, n times n times n times n. There you go. There's 5 of them. That's n to the 5. Okay? If I wanted to do n to the 4, same idea, except there's 4 of them. So there's n to the 5, and there's n to the 4. So I've just written it out in longhand. Now, how many n's are there being multiplied in total? And it's 9. It's 5 plus 4. So that's where your n to the 9 comes from. Okay? So that's about recognizing your index laws. Here, they step it up a little bit. You can see you've got 3 things that you've got to treat separately. You've got the 5s and the 7, the numbers. So you do them. That's what you get 35 from. You've got the letter p. So you've got a p cubed and a p to the, that's actually a 1 there, right? So 3 plus 1 gives you the 4. And then you've got a q, that's also a 1, q to the power of 1. Q to the 8, 1 plus 8 gives you 9. So you've got the 3 things, you've got to do them all separately in order to get the 1. It's very easy to muddle them up, okay? So if you got that one wrong, that might have been why. Now, when you go to this one, simplifying this, because it's division, just to write it out again, I'll just skip writing the times signs. If I do 9 of them, that's 7, 8, 9, and I'm dividing by 6 of them. So just like you normally would with a fraction, you can cancel things out. You can cancel that one, that one, that one. You can cancel 6 from the top and 6 from the bottom, which, well, I've cancelled 1 too many, sorry. So you're left with 3, because 9 minus 6 is 3. So your index laws here and here is what was being tested for all of these, really. Here, m to the, it's a bit hard to read, 5 all squared, right? So again, that's 5m's times 5m's. Because that's what squared means, right? You multiply something by itself. So how many m's are there in total? There are 10. Simplify, this works the same way, but the trick was that you've got to square the 3 and square the m, because this is 3m times 3m. Again, that's what squared means, right? So you've got the 3's, which become your 9, and you've got your m's, which become your m squared. Lastly here, bit of a sneaky thing here, 4 times m to the power of 0. Now, you might remember when we were trying to work out the power of 0, when you thought about, M1, M2, M3, what they're short for, and if we went backwards and tried to look, you go here, you divide by M, you go here, you divide by M. If you went one more time, M to the power of 0, that's just 1. Okay? So that's why 4 times 1 just gives you 4. Okay? So M naught 1. Over the page. Factorizing, so we did expanding in the previous question, so this is just in reverse. You look at these two terms and you're thinking about what's the common factor. Okay? So you can see, you can take out the 3, that's good, but you can also take out the x. So once you've taken the 3x out the front, you think, well, what's left after I divide this by 3x? What's left is just the y. Right? What's left in this after you divide by 3x? And it's just the 2. So there's where your y and your plus 2 come from. Okay, now, then you start getting into the fractions, right? Now, here they start off with a simple one where the denominators are the same. So since the denominators are the same, you just add the numerators together. And that's where you get 4m from. The 11 stays put. Okay? Just to give you a simpler example without algebra, right? If I gave you a half plus a half, everyone knows when you have 2 halves, you get 1, right? So numerically, what are we talking about here? That denominator stays the same, and it's the numerators that add together. And 2 over 2, of course, is 1. So we're applying the same principle here. It's just that they're letters, not numbers.
Why is it wet?
Okay.
I'm sure there's some context that makes sense of that. Okay, now, 13. You've got to change the denominator, don't you? Okay? You've got 7 and 14 here. So to get a common denominator, you could multiply this one by 7 and this by 14, but it's much simpler to just make this one over 14. Then they've got the common denominator, right? So some of you would have, when I had a look through, you struggled to work out what was the best common denominator to get. There's lots of different ones, but the simplest one is 14. So what you'd have to do is, if you're doubling the bottom to get 14, you've got to double the top to stay the same fraction, okay? So that's why 3x becomes 6x and the 7 becomes 14. Once they're on the same denominator, you've got the same scenario as you had here. And so you've got 6x minus 2x, which gives you 4x. Now, that's good, that's correct, but they did say simplify, right? So therefore, we should really go from here to here. The difference you can see is they've cancelled the factor of 2, okay? So that's the difference between this and this, and you did have to go all the way to here. When you're multiplying is actually really easy, isn't it? You just multiply the numerator and multiply the denominator. That's what gives you x, y, and 15. When you do division, all you have to do is dividing by, for example, if you divide by 2, that's the same as multiplying by a half. So division and multiplication is the same idea if you take the reciprocal. You turn the number upside down. So that's why this 4 over b, it turns into a b over 4. Flips upside down, becomes multiplication, and then it's just like the previous question. Okay? Alright, before we get into probability, I'll pause. Does anyone want me to clarify any of the questions I went through? Yeah.
Could you clarify the last one?
This one here? Yeah, okay. Let me try and give you a simpler example. If I said, okay, 10 divided by 2. Now you guys can all tell me that that's 5 because we know how to do it with numbers, right? But with fractions, it's a bit trickier. So the way we remember it is 10 divided by 2, just following on this principle, is the same as 10 multiplied by a half. So you can see I've changed the division into multiplication, and I've changed this 2 into its reciprocal. Okay, I've reversed it. So that's 10 over 2, which, as you were telling me before, is 5. Okay, so the point is that when you divide by a fraction, you turn that fraction upside down. This was 2 over 1. Okay, in the same way, if I were to do it this way, 10 divided by a half, what would that be equal to? That's how many halves are there in 10? The answer is there are 20 halves in 10, right? But the way that I would write that is turn that division into multiplication, and I would flip this fraction upside down. It becomes 2. That gives me the 20. There are 20 halves in 10. If I had 10 things and I chopped them all in half, I'd have 20 of them. Okay, so that's why the way I try and remember it, that the division turns into multiplication, and you get the reciprocal. You flip the fraction upside down. Good question.